about today how to find oxidizing agent and reducing agent if the reaction is given. So the first step that you are going to do is to mention the oxidation state on the top of the reaction. That's how you will proceed in your rough work. You can do that, or you can do that in your fair work also. So first let's start with the rules. That's why the rules are very important. So here we know by the rule that hydrogen in most compound is +1. So we will designate +1. And remember, you don't worry about the subscript that how many hydrogens are there when you designate the oxidation number on the top. You just worry about the element. That's it. So we know hydrogen in most of the compound is +1, so we give it +1. Carbon we don't know at this point of time. Here O2, it's a uncombined one, it's a pure one, so it will be 0 according to the rule. Here we know oxygen in most of the compound is -2, and as I told you, we don't worry about the subscript, so we just write -2. Here oxygen in most of the compound -2, and hydrogen again most of the compound +1. Again I am telling you, we don't worry about the subscript, so we have this one. Carbon we don't know, so we have to find about carbon. So first say carbon oxidation state in CH4. Let it to be X. Then what we know, we can write this like this, CH4. So we have 1 carbon and 4 hydrogen. So what's the charge on hydrogen? It's +1. Do I need to write +1? No, I can write just 1. It makes sense. So now I can find X from this equation. X will be -4. So oxidation state of carbon in CH4 is -4. So can I write it here? It will be better. Then carbon oxidation state in CO2. Again, let it to be X, or you can assume it to be Y. It's up to you. CO2 X plus how many oxygens are there? 2. What's the charge on one oxygen? -2. From the rule we know, equals to 0 because there are no charge on it. So X -4, because 2 multiplied by -2 gives you -4. X equals to 4. So oxidation state of carbon in CO2 is +4, right? So we mention +4 here. Now as we have oxidation state of every species in this reaction, that's how you are going to check. So see, I have oxidation state of carbon here, I have oxidation state of hydrogen, I have oxidation state of oxygen, I have oxidation state of carbon here, I have oxidation state of oxygen here, I have oxidation state of hydrogen, oxygen. That's great. So for carbon, how the oxidation state has changed, so we can say from -4 it is going to +4. So for carbon it had went from -4 to +4. That means increase in oxidation state, which means we have done oxidation, or carbon got oxidized. If carbon got oxidized means it is reducing agent, because it will be reducing something. Now let's find out which thing is reducing. So the next species is hydrogen. Let's see what's the oxidation state of hydrogen. Here it is +1, here it is also +1, so there is no change. So if there is no change, we don't worry about the hydrogen. Let's look at on the next species, which is oxygen, because there is no other species. From carbon, hydrogen, then oxygen. So oxygen, in the left hand side it was 0, on the right hand side it is -2, so 0 to -2 means decrease in oxidation state. This means reduction. So we can say oxygen has been reduced because oxidation number decreased. And if it has been reduced, so who reduced it? Our reducing agent, which is carbon, and this has oxidized our carbon, so it will be oxidizing agent. So from here you got to know what is your oxidizing agent, you got to know what is your reducing agent, which species is getting reduced, which species is getting oxidized, and how the oxidation number changes for all the species. So this is what mainly going to be asked in questions. So you have to keep in mind, the most important thing is you never mention oxidation state of species with its subscript. I could have mentioned here +4, but I don't do that. I just mention the oxidation state of the pure element. That's it. What's the oxidation state of hydrogen? Here, what's the oxidation of oxygen? That subscript is taken care of in this formula. Okay, so don't mention it with subscript. Cool. And you have to see which species is pure, which is not. If a species contains two element, it is not pure, like HCl. It is not pure because it contains hydrogen also, chlorine also. So then you have to mention chlorine is -1, hydrogen is +1, like that. So thank you.